Hey, okay, notes, part 2 here. We're going to talk about key attributes of quadratic functions. So you already know key attributes of linear functions. Those are the things like the y-intercept, which you see on here, x-intercepts. We already know that they're also called the zeros. Domain and range, of course, comes in. And then we have some new terms, minimum, maximum, which we talked about with domain and range. And then vertex and axis of symmetry. Okay, so let's go get started. The quadratic unit is a little bit strange because like all these things kind of come up and it's kind of thinking about what's the best order. So some of this you may have seen in notes previously, and you might see it again next week in notes, but that's okay. All right, again, you should be taking notes. Now, the key attributes of the function is going to come kind of towards the end. So what I did is made that slide, and I'll tell you which one it is when we get there, as a separate slide to share with you in case you want to put that into your notes. If you have digital notes going on, or if you want it to print it. Otherwise, you just get your journal out and write down the important parts from here. And then you can draw that diagram in your notes. Okay, again, did slides, so you don't have to read my writing. So let's get started. All right, the standard form of a quadratic function is, now we could say y equals, or you could say f of x equals. So I wrote them both here. And that's ax squared plus bx plus c. Just a cannot equal 0, because what happens when a equals 0? Then you have bx plus c, which is mx plus b, which is linear, not quadratic. Okay, so that's the only thing. A can't equal 0. B could be 0, c could be 0, but a cannot. Okay, so not that important, just a little technicality there. Okay, so quadratic, again, functions have the x squared, and so the standard form is going to be the ax squared plus bx plus c. Now, a might be equal to 1, so things like x squared plus 2x plus 3 is in standard form. 3x squared plus 4, also standard form. Okay, all right, so moving on. I don't think there's anything else I wanted to say. We're going to talk about how to graph a quadratic function without technology, because yes, I know you can go to Desmos and put this in and see the graph. And if I was taking a test answering questions, that's exactly what I would do. The release star questions that I looked at about key attributes are pretty much all graphs. They give you the graph. But it's important to know how to do these things without technology. Because you need to know how all the pieces work rather than just what the graph is going to look like in the end. So when we are graphing a quadratic function without technology, we're going to do just like we did with linear. You're going to pick values for x, substitute them in to get the y values, and then you have points to plot. And that actually came in handy. We were doing something with slope, and you guys you did that. You fell back on that skill that you learned probably back in, I don't know, 6th grade, 5th grade, whenever you start plotting points. I guess 5th grade, because that's what my daughter's doing now, plotting points. Okay, so y equals x squared. So we are going to pick values for x. Now, it's important in algebra, or wherever you're looking at a function, you need to know what the function does when the input is negative, when the input is 0, and when the input is positive. So you can't just do like 1, 2, 3 and go from there. Okay, so you need all of those. And in quadratics, it's going to be important. I'll show you in a minute. You need to have at least 3 points to plot this curve, but you need to have the correct 3 points. You'll see what I mean as we go on. All right, so let's pick for x. Let's see how many spaces did I give us. Let's pick -2. I think I didn't give us enough spaces. -1, 0. Oh yeah, I did. 1 and 2. Now I gotta say, usually I just pick -2, 0, and 1. But in quadratics, sometimes those end up being really close and it's hard to get a nice parabola. So you should start -2, -1, 0, 1, and 2. Now, I don't have a fraction, and I didn't think to put one in this presentation, but if you had a fraction like 1/2 x, you want to pick values of x that will eliminate that fraction. So like 2, 4, 6, those kinds of things. Okay, so you might want to be really specific about what x values you pick in order to get rid of the fractions, because it's much easier to plot integers. Okay, so the process is what am I going to do? So y equals x squared. So -2 squared is negative 2 times negative 2, which is positive 4. Negative 1 squared, negative 1 times negative 1, which is positive 1. 0 squared is 0. 1 squared is 1, and 2 squared is 4. So if you look in your table, you see that your values are decreasing from here to here, and then they start increasing again. So I can see that this kind of turns around, so to speak. Oh, that's not pretty. Hang on, let me try to write that better. It kind of turns around at this point and heads the other way. Okay, that's going to be important for one of our key attributes. Okay, so let's plot these points. I guess I'll use blue. So I'm going to plot negative 2, 1, 2, 3, 4 right here. And I'm just going to assume, as I will if you give me anything on paper, if there's no numbers on here, I'm going to assume everything represents 1. The hash marks are 1. Okay, and then I have 1, 1, 0, 0, 1, 1, negative 1, 1 rather, 0, 0, 1, 1, and 2, 4. Okay, so I see that this curve is going to look like this. I am not the best parabola drawer. I missed that. But not too bad as parabolas go. Let's see if I can try again. Make sure I hit that. Oh, I missed that one. You get the idea. Okay, so it makes this U-shaped, okay? So this right here, this is what we call the parent function. So next week we're going to look at transformations of parent functions. And we didn't really do that with the linear functions. I just skipped it because it makes a lot more sense when we look at the quadratics. You can see what's going on better. And then after we're done with the quadratic transformation, we'll go hit some linear stuff as well. Okay, so the parent function, not functions, of the quadratic formula, or the quadratic function, is y equals x squared. Parent function, like the very most basic thing you could have. Like the parent function for linear was y equals x. Okay, so y equals x squared is the parent function for quadratics. Okay, and it's always going to look like that. All right, try another one. Again, without technology. Negative 2x squared plus 1. I know it's quadratic because I have that x squared term. And again, I'm going to pick negatives, 0, and positives. 2, negative 1, 0, 1, 1 to 2. Okay, and so now, I should have made my process column a little bigger. I'm going to do negative 2 times x is negative 2. So negative 2 times negative 2 squared plus 1. Okay, and that I'm going to go do down here so you can see. Now, of course, if you're using a calculator, you could just put that and hit enter in. But if not, negative 2 squared with 2 squaring first, according to PEMDAS, is 4 plus 1. Negative 2 times 4 is negative 8 plus 1, and negative 8 plus 1 is negative 7. 1, 2, 3, 4, 5, 6, 7. Okay, I wasn't sure it was going to work. Negative 7. Okay, so now I have negative 1 times negative 2 plus 1. So negative 1 times negative 2 squared, plus 1 squared. So negative 1 times 4 plus 1, negative 4 plus 1 is negative 3. Okay, then I have 0. Oh, wait, I messed this up. I'm so sorry. Too many things, thinking about too many things at once here. Oh, I can't get rid of all this. Oh, I can get rid of the stuff that's wrong. Never mind, rewind, which I think I could, but you know, I don't feel like figuring that out. A and B, everybody makes mistakes. It's okay. So, forget what I just said. Rewind. Let's start again. This is negative 2 times negative 1 squared plus 1. You're substituting the x values in for x. So the negative 2 is going to keep being constantly multiplied. Okay? Oh, this is still negative 7. All right, so negative 2 times negative 1 squared plus 1. Negative 2 times 1 plus 1. Negative 2 plus 1 equals negative 1. That makes more sense. Okay? All right, so make sure I did that one right before we go on. Yep, looks good. Okay, so now I have 0. So negative 2 times 0 squared plus 1, which is just going to be 1. So I have a turnaround point, looks like here, because now I'm decreasing, or no, increasing. Okay, well, let's see what happens. That might not be what I think it is. Okay. Negative 2 times 1 squared plus 1. So negative 2 times 1 squared plus 1. I'm still going to get negative 2 times 1 plus 1. I'm going to get negative 1. And there it is. That's where I make my shift. Okay, and then so negative 2 times 2 squared plus 1 is going to give me negative 7. Okay? All right, so let's graph this and see what happens. So negative 2, negative 7. 1, 2, 3, 4, 5, 6, 7 right on the edge here. And then I have negative 1, negative 1, so right here. Then I have 0, positive 1, and now I'm going to turn around and come back to 1, negative 1, and 2, negative 7. So now my parabola looks like this. There we go. Okay, so how is it the same? How is it different from the previous one? So I'll give you a minute. Think about it. Pause the video. So probably would say the first one looked like this. The parent function was like this. And this one's upside down. Okay, so let's look at the equations. That was the equation for that one. Here's this equation. So the one that goes upside down has a negative coefficient. Okay, and that's important to note because that will kind of help you with reasonableness of an answer. Okay, which I believe is our next slide. So let's see. Yes. So we call this concavity. Is this concave up or concave down? So if a, which is the coefficient of x squared, is positive, the parabola will open upwards, like so. We call this concave up, and the function will have a minimum value. So this is your minimum value. It reaches a low point, and then it heads back up again. Okay, it's like the turnaround point, but it's going to be at the bottom of the U. Okay, if a, the coefficient of x squared, is negative, then the parabola opens downward, like this. And we call that concave down, and the function will have a maximum value, which is right here. So it reaches a high point and then comes back down again. Okay, so concave up, like think about diving into a pool. You dive down, you reach the bottom or as far as you can get, and then you head back up to the surface for air. And then maximum, if you're like throwing a ball or a paper airplane, it's going to go up, reach a maximum point, and then come back down to the ground. Okay, so you need to look, if your quadratic starts with a negative number coefficient of x squared, it's going to be downward. And if it's positive, it's going to open upward. Okay, so here we are with the key attributes of quadratic functions. And this is the slide that I did link, or I will link in there. I made just this slide. So you can add to it whatever you need to. It's going to look just like this, not with any of the writing I'm going to put on it right now. So I guess I could make this I always make them a video. I could save it as a PDF. If you want that, like a transcript of the video, just send me an email and I'll send that to you. But I wasn't going to put it on the classroom necessarily. Unless you think it's important. If y'all do, if you have an opinion, please let me know. Okay, so key attributes of quadratic functions. So you have your y-intercept here, like always, and that's where x equals 0. Okay, so it's wherever x equals 0. So when you put a 0 in for x into your function, you find your y-intercept. Okay, now in our last two examples, the y-intercept was also the vertex, but that's not necessarily true. It's only true because of the functions I chose to make sure I had numbers that were going to fit on our grid. Okay, x-intercepts. In quadratics, we call these the solutions. You also know that they are called the zeros. Zeros, x-intercepts, solutions, and they're also called, and you'll learn why a little bit later, they're also called the roots. Okay, and so I used to have this little foldable thing we used to do, and we called them this. Roots, zeros, you make a 0, oops, 0, x-intercepts, and solutions. They all mean the same thing. They're all these points here where the parabola crosses the x-axis. Okay, so you know x-intercept is the zeros from linear functions. Just now in quadratics we call it solutions or roots as well. Okay, and then new terms, we have the vertex. So the vertex is going to be either a maximum or minimum, and in this point, this example, let me get something, a better green to use. I need a dark green. Sorry, I guess I could pause to do this. There we go. Okay, in this case, this is a minimum. Okay, so your vertex is either your minimum or the maximum. It's a minimum because it kind of bottoms out. That's the lowest it can be before it starts going up again. Okay. And then this line that goes through, if you look at a parabola or a U-shape, it has this axis of symmetry. Like if I fold this paper on the axis of symmetry where the vertex is, it's going to match up. You're going to have the same values on either side. So here and here, here and here, here and here. Okay, so the axis of symmetry. Now the axis of symmetry is a line. So therefore it has a equation. So the axis of symmetry is x equals, and it's whatever the x value of the vertex is. So let's go back. The vertex here is 1, 2, 3, negative 4. Okay. This line that goes through 1 is called x equals 1. Okay. So lots of people always say to me, so is the axis of symmetry the x value of the vertex? Yes, always. The vertex is a point on the axis of symmetry, and it's kind of that turnaround point where your function, you know, in this case is decreasing, reaches a minimum, and then increases again. That's your vertex, okay? And in this case, it's a minimum point, okay? So it's a minimum, and if I wanted to talk about the minimum value, I would say that is negative 4. That's the y value of the vertex, okay? Usually they just want you to know, is it a minimum or a maximum? And then what is the vertex? So that's an ordered pair. What is the axis of symmetry? And they usually want the equation for that axis of symmetry, so it's x equals 1. Okay, so these are going to be the same. Let me find a, I'll choose gray. Okay, so this x value is this x value, okay? All right, and I did not write down the y-intercept, so let me go do that. Hang on, I have a purple. Here we go. So the y-intercept is, oh, it would be good if I was using a pen though, and not a highlighter. 0, 1, 2, 3, negative 3. That's the y-intercept. Okay, and remember, the y-intercept is an ordered pair, but a lot of times they just want the y value, and they'll just want you like to grid in a negative 3. Okay, and then the x-intercepts, in this case I have two of them. So my zeros, I'll write that over here, or my x-intercept is, let's see, -1, 0, and 1, 2, 3, 0. Okay, and if you look at your x-intercepts, you'll see that they are both 2 units away from the axis of symmetry. Okay, in this case. Alrighty, so new terms, vertex, which is either your minimum or maximum value. It's kind of like that lowest or highest point. Kind of like if you're thinking about like a mountain, it's like the apex. Sometimes they'll call that the apex of the mountain. Okay, and then the axis of symmetry is that line that cuts the parabola into two congruent sides, so to speak. You know, you guys talked about axis of symmetry. It shows up on the 4th grade STAR test. You know, how many lines of symmetry do you have? So same thing as that line of symmetry cuts the parabola in half, and if you fold on that, it's going to match up, and it goes right through the vertex. So either find your line of symmetry, then you got your vertex, or find your vertex, and now you got your line of symmetry. Okay, they are related. Okay, all right, so let's practice on, well, actually, I think let's see what's next. Yes, before we practice. How do I know how many zeros, x-intercepts, root solutions, a quadratic function has? So think about that. Think about the parabolas. How many times can that parabola cross the x-axis? So I'll give you a minute to think. I'm going to get some coffee. Okay, so in our first example, we said it could cross twice. Hang on, I got rid of my blue color. Okay, so it could look like this. Okay, so it crosses once, twice. So it could cross twice, in which case it would have 2 zeros, or 2 solutions, or 2 x-intercepts, or 2 roots. Okay. But also, as we saw in the first examples that we looked at, it could cross just once, like the parent function crosses just once. Okay. Nope, that doesn't cross once. Well, yeah, it does at the origin. But let me draw a better example. Let's do like this here. Try and make sure that I show you all kinds of things that can happen. And of course, we will be assuming that this is crossing here. Okay, so it could cross once, in which case it would have 1 zero or 1 solution. Okay, and then there is one other thing that can happen. I could have a quadratic function that doesn't cross at all. It's up here somewhere. Or it's down here somewhere. Okay, so it could cross not at all. So I guess I could say not at all. Not at all, I guess I'll say, and that would have no solutions. So I know this idea of no solutions have come up several times this year in Algebra 1. So just know that I could have a quadratic, could have 1 zero, 2 zeros, or no zeros. Okay, it doesn't have to cross the x-axis. Okay, it will have a y-intercept though. I mean, eventually it'll have to cross the y-axis. You might not see it on your graph depending on your window or what the situation is, but eventually it will cross the x-axis, or y-axis rather. Okay, all right, so let's look at this practice, and then you guys, I'm going to put a couple of these that look like this. I'll make them into a slideshow, I think, for you to fill in the blanks and hand in, okay? All right, find the key attributes of this graph for this quadratic function. So, the x-intercepts. Oh, of course, I did not pick an easy one. All right, so the x-intercepts are going to be here and here, so I have two of them. Okay, so I'm going to call that negative, I don't know, 1.2 and positive 7.2. Okay, I'll try to make sure the graphs that I pick, I just took this from something the district gave me, and I didn't notice that the x-intercepts were not integers. Okay, y-intercept, that one I did look at. The y-intercept is right here, and I'm going to call that 0, 8. Okay, so 8. I'll just write 8. Even though, you know, technically these are ordered pairs, but I don't have a lot of room here. Okay, the zeros again are the x-intercepts, so negative 1.2, comma 0, and 7.2, comma 0. If you just write the numbers, I'm okay with that too. Now, does this have a minimum or a maximum? Well, it's concave down, it has a maximum, so there isn't a minimum. The maximum point is right here at 18. That's also my vertex point there. So my vertex is at, sorry about that. Okay, vertex is at 3. Oops. Ay, yay, yay. 3, 18. Okay, the axis of symmetry is this line that's going straight down through the vertex, and that's at x equals 3. Okay, I need x equals, don't just tell me 3. Okay, now, just for fun, let's do domain and range here. The domain of this function is a quadratic function on a graph, you know, like this goes on forever. So my domain is all real numbers, okay? And then my range is anything less than or equal to 18, since that's my vertex. This is a point on a line, so it's colored in, so it's less than or equal to. And it can't be higher than that. That's why it's called the maximum. Okay. All right. If you have questions, you can comment on this video in the classroom, or you can email me, or you can do Google Meets. And then let me know, and I will try to find some videos for you if you want to do this. I'm not sure. Key attributes, I seem to remember looking on Khan Academy previously, last year and stuff for this, and it's kind of this thing that we kind of do for the TEAC, but it's always in other lessons and videos, it's like embedded in all these other lessons, so I don't know if we can pull it out. Likewise, you're going to be really sad there's not really a Math Excel that does just this, okay? So do the Google slide that I'm going to do next. That's underneath this video, and then make sure you turn that in so that I can see how you're doing. Okay, bye.